because some of you probably live in older homes in Cleveland, you may be tempted to use one of these. Um, so let's look at what this does. This allows you to plug your three-pronged device into a two-pronged outlet. Now, in principle, when these first kind of came into being, you would also take the screw out of the faceplate. So you got your outlet here, and you got your screw on the faceplate. And what these were designed to do was you take the screw out, you'd plug this in, you put the screw back in through that, and the metal casing in behind all of this was grounded. And so when you screwed this into the metal casing, you were actually replacing this third prong, not with a prong here, but this connected to the ground. The problem is that's not true in most places anymore. So that no longer connects to ground, or the screw right here no longer connects to ground. And so when you do this, you're potentially setting yourself up for some trouble because um, because that means you're probably using an electrical appliance of some sort with this, and now it doesn't have ground to bleed off charge. Now I'll give you some devices that build up charge readily. Printers, printers. Um, and I've had to take off my list the old CRTs, right? You guys remember the old monitors? There were these big ginormous things, the big ginormous TVs with the 20 pounds of glass or 40 pounds of glass out front. Yeah, they built up charge, but you guys don't have any of those anymore. But printers use charge to print. And so if you have a printer that's not properly grounded, it will build up a charge and it will eventually shock you. Um, I said this to a chemistry prof once back when I was a freshman, and he was using one of these for his printer. I said, "Hey, that's not good. You're going to build up charge on your printer and it's going to shock you." He's like, "Oh, no, no, it's fine. I've been using it for a week or so." The next week, he said, "I've moved it because it shocked the bejesus out of me." Um, so this is a safety issue. Ground everything, right? Really important. Ground everything. Unless you're working with, you know, 15,000 volts, you want everything grounded. When you're up there, you kind of want the option to not be grounded. Okay. Um, what are the other issues around safety? Don't pick up a wire off the road if there's been a downed power line because, well, you get to look comic like this guy, right? You touch the hot wire, you now offer a alternative path to ground. And final bits, what kind of scale are we talking about? At 1 milliamp, sorry, you feel it. At 5, no big deal. Okay. 10 to 20, muscular contraction. Now this brings up a different issue. If you are looking at a wire and you need to find out, and you'll watch old electricians actually touch boxes this way, you need to find out if it's hot. Don't grab it like this. Why? You grab it like this. Your muscles contract. Now your muscles are involuntarily holding on to the wire and you cannot let go. Instead, touch the wire or appliance with the back of your hand. What happens when you touch it with the back of your hand? That involuntary contraction causes you to pull your hand away from the source of the electricity. And so you'll see older electricians whenever they go up to a breaker box, tap it with the back of their hand. Why? They're checking for safety issues. Okay. 50 onset of pain, 100 to 300 milliamps. This is where we shock you to get your heart going or stop, right? 300 burns depending on the concentration of the current. Yeah, I put myself in parallel with a AM radio station once, and it burned my hand in both places where my hand touched. Unfortunately, once it burned the skin, it didn't conduct as well. And then you can, up around 6 amps, you're really in trouble. You can stop the heart, you can start the heart, all kinds of things. All right, and so that's it for electrical safety. Be safe out there. Don't do stupid things.